Alrighty. Okay, I'll kick it off. Okay, so thanks, Jess. So I'm here to give everyone a little bit of, I guess, introduction on the operational technology and how system thinking is helping us in the modern age of digital age of the transport infrastructure. So you're probably already aware there's a bunch of digital initiatives that's happening across the industry at the moment. And currently I'm basically working on what we call ETCS projects, which is a digital system almost that is basically an OT that has been modernized to the current modern standard of digital age. And I'll sort of go through how the system thinking is used in operational technology projects today. Okay, so I guess I want to start off with a definition of OT. So one I generally tend to use quite often is a one from the 62443 standards. So basically, they describe a OT as a collection of personnel, hardware, software, and policies involved in operation of industrial process, and that can affect and influence its safe, secure, and reliable operation. So that's quite wordy, but I hope that as we go through the presentation today, you'll have a bit more of an insight of what this actually means and how that can be applied to your OT projects. All right, so I want to sort of give a little bit of typical OT systems used in transport industry. So here an example of an ETCS system. And if you actually look at from afar, the typical OT system is consisted of your actuators, sensors, controllers, and the human machine interfaces. So in this particular example here, your actuator is, for example, your brakes, and your controller is your onboard system. And the sensor is your either your axle counters or the bodies, which sort of gives the location data set to the trains. And human machine interface in this case would be your driver dashboard, right? So the way typical OT systems sort of work is that it will always have a control logic that's built in to the overall system, and a trigger is a particular action when a certain condition is triggered. So, and as you can see, that loop of sensors detecting the particular event gets processed through the controller, and actual physical action that happens in the physical world. And that's probably a very important point there. And obviously the control process is that your actual train running, and your feedback loop is basically ensuring that your predetermined action that's given by the controller is correct. So that is always going to be some sort of feedback loop there. All right. And here's the sort of the typical OT system architecture. And when I talk to the industry colleagues about OT, what people generally sort of perceive it as more of a manufacturing sort of terminology that gets used quite frequently. So the common, like your PLC control systems, which has the programmable logic controller that has like field bus interface to your sensors, and the HMIs and the actuators, in this case, the servo drives and things like that, would be a sort of common use case in the OT environment, in a manufacturing environment, right? But I guess today we're talking about the transport sector. So I'm sort of have an example here of how the rail monitoring and control system is implemented in our industry. So I won't go into too much details of what each one of those, because that's not what they're here for. But general thing that I can sort of provide you is that there's always going to be a human machine interface, and there's always going to be a sensor and the actuator, which is triggering physical action. And there's always going to be a control logic. And as you can see in the blue side in the bottom, is where a lot of those are happening. And the HMI and the management protocol is more sitting under, in this particular scenario, in a rail control center. And that's quite one of the reason that the color scheme is slightly different, like blue and yellow, or blue and orange, depending on how you see the colors. But the key thing here is that one of the key theme in the modern day OT system is that there's always going to be some level of a IT-OT integration or IT-OT convergence, and it is quite evident generally in a centralized control center. So in this case, rail control centers, where you actually have a mixture of OT systems and the IT systems and work in conjunction to provide a business logic there. All right, so let's just quickly discuss the key characteristics. I know I'm sort of going into too much of the basics of what OT is. Hopefully everyone's already across it, but it's always sort of good to sort of remind everyone why OT is actually different from like a lot of what we call IT. So one thing that I like to use in generally to describe the characteristics of OT system is the pyramid level. This explained in the ISA 95 standards. So the way they interpret it is that you have 4 different levels from level 0, sorry, 5 different levels from level 0 to level 4. And as you go down into the pyramid level, so your bottom level, which is level 0, will be your field devices, and then you have a local control logic on top of that, and then you have a distributed supervisory functionalities, and then you have a planning function, and all the way up to the business management function. And the typical OT boundary, IT-OT boundaries happens between level 3 and level 4. And if you look at the characteristics of these, it gives you a sort of indication why OT is very different from IT. So some of the key aspects that they're they put a high priority on, especially as you go down to the level, is your real-time real-time logic. So when I say real-time, I sort of put there hard real-time. So there's what we call soft real-time and hard real-time. And the hard real-time is a something that you need to make sure that particular, let's say a data set or the information has to pass on to the actuator in time. Otherwise, it will have a significant, potentially safety implications. So soft real time is real time enough almost. So, that's why usually the term hard real time is used in OT, and the IT generally uses real time, but that generally means soft real time. Another sort of key characteristics is that it has a very highly reliability and availability requirements for obvious reasons, because the OT systems, you don't want it to have a high failure rate, as an example. So, and you need to make sure that availability is acceptable. And that's why, like a lot of OT systems, you put huge amount of effort in trying to understand what that reliability figures are, what that availability figures are. And last but not least, we already sort of had a discussion, safety critical. So there's a little bit of caveat there, because not all OT systems are actually safety critical, but the majority of the OT system does carry operational critical functionalities, which does translate in many of the systems as a safety critical implications. So these are some of the key characteristics that you actually need to consider when you're actually designing a OT systems. All right. So I guess I want to sort of go into a bit of a in-depth understanding of why the modern day operational technology is becoming more complex. So there's largely sort of 6 reasons behind that increase in complexity. So I think I sort of mentioned before, there's a huge amount of IT-OT integration. So traditionally, if you look at traditional sort of legacy OT, what you notice is that the way they achieve, like manage this so-called complexity, is that basically they'll have a siloed approach, right? So OT system will have its own network, OT system will have its own servers, OT system will have its own hardwares and softwares. that is completely isolated from IT environment. However, with the modern day digital OT, what tend to happen is that that boundary is starting to become a bit gray, right? So, and that's sort of starting to introduce a lot of risks and complexities into that as well. And the next sort of the key one is the Industry 4.0 adoption. So I think the easier one that everyone understands is the IoT, the Internet of Things. And this is quite a, like, people don't quite necessarily see it as something that's already here, right? But if you actually think about some of the advancements that's been happening recently with AIs and um, like you see on the news about self-driving cars and things like that, you are actually relying on distributed IoT systems, and that each of the edge sort of computing mechanisms already making a lot of decisions for you. Um, and this is actually quite a common like evolution like over the history. So if you look at the old generation cars, everything's mechanical, like human has to make sure everything is. But if you look at the modern day cars, you'll see very high compute, like that's actually processing a lot of digital data, making decisions, like traction controls and things like that. So, and I guess 4.0 is a sort of like going a bit further with like, all right, we'll actually have a huge amount of data set that's going to be required in order to make a decision that will translate into the physical action. And that particular, I guess, principle is being more and more accepted by the industry compared to the traditional OT. And that's quite apparent in the recent years, especially with the advancement of AI. I feel like that's something that's we'll probably talk a bit more about it when it comes to safety side of things. But the general industry consensus that there's definitely a bit more of an acceptance compared to the past in terms of how they will treat the Industry 4.0 adoptions. And the next complexity is quite straightforward, interconnectivity and the dependencies. So with the modern day operational technology, what you'll notice is that it is actually very much a distributed architecture. So what that means is that you'll have a quite large amount of subsystems that's actually interacting each other to actually provide a particular end-to-end function. And within that complex web of interconnectivities, and you'll see it has a linkage to things that you may not even think should belong to OT, and that happens quite frequently. And to understand, to manage and understand that, you need to have quite a holistic view of things and very stringent ways of managing those interconnectivities and dependencies as well. And the legacy integration challenges is quite a interesting one because I think it's sort of going back to that old mentality of, all right, we're just going to isolate everything between OT environment to anything external. And that seems to be sort of industry's current sort of industry practice in terms of managing sort of legacy integration challenges. However, at least from my experience anyway, that is not necessarily something that works that well with the modern day environment. So as soon as you're starting to bring in the legacy, let's say OT subsystems into the fold of the modern day digital era, you're starting to notice some of the gaps within how they implemented their OT logics. So some of the classic example is the old cybersecurity your measures that you want to implement into the legacy integration system, and you're looking at end-to-end like encryption, for example, of the system and data transmitting between the systems. And if you have a legacy system which is just only gonna send unencrypted data. Like, how do you sort of manage that sort of integration? So you only see that now that you're starting to bring that outside the boundary, that boundary that was originally set from the previous like project that has rolled out the legacy systems. And the regulatory and safety demands is quite a big one as well, especially in the transport industry. We have a very stringent regulatory and the safety requirements. And especially with OT, the way they, once again, way they just sort of manage to get around that in olden days is to not expose it to any external systems, right? Where everything's isolated, and then if you need some sort of interface between two systems, which one is not necessarily meeting that stringent regulatory and safety requirements, it'll be handled from the more policy side of things or from process-driven side of things. So like good example is like your disaster recovery systems as well. And cybersecurity, I left it to the last. It's generally what gets discussed the most when you talk about the operational technology. And I didn't want to focus too much on that because that's sort of like displayed and everyone sort of talks about it, and it's quite a big sort of news that comes out into whenever there's a cybersecurity incident. But it is a big issue. So especially you're increasing your attacking surface area of your OT system vastly with the modern architecture. So you really need to put a very good sort of security policies, very good security architecture, like from both system architecture wise and the policy wise. You need to have a very solid way to secure your OT systems nowadays, and you like, at least just from my observation of a lot of OT systems around, that is not done too well, if I'm being perfectly honest. So it is a big challenge. Majority of the transport sectors need to address in coming years, I'll say. Okay, so I want to sort of do a little bit of deep dive in how we apply the system thinking to address some of these challenges. So let's start with the IT/OT integration aspect of it, because that's what we commonly discuss as quite a big challenge. So I guess from the challenge perspective, and this is sort of like based from the real projects. These were the identified sort of challenges that we typically find. So we tend to see a lot of the conflicting operational priorities. So I think we sort of mentioned about how OT systems, their main focus is on safety, hard real-time safety, and reliability, availability. You probably see IT systems talk about availability quite a bit, but their way of interpreting availability is very different to the OT systems, right? So because the degraded mode within the IT systems are recovered in a sense that it just needs to meet the business continuity. That's it, right? But from the OT point of view, your operational priority has to make sure it is met. Otherwise, you need to put a sort of almost like a safety mitigation case around, because the small mishap in the operational priorities within the OT system can cause huge like safety issues. So and that integration has that conflicts between. So if you have a system that's containing both portion of the IT subsets and the OT subsets, there's a lot of discussion that happens, and it can cause a huge issue for projects. And to address that, I guess from the system thinking approach point of view, you do need to make sure you identify and make sure you map critical interdependencies between OT and IT. And that's the only way you see, like, I think I sort of mentioned the spider web sort of viewpoint. But if you are able to map your interdependency between OT and IT, when you classify elements into that aspect and start providing the interconnectivity information into the fold, you start to see the system boundaries sort of forming between OT and IT, and that's like how you can sort of tackle some of these issues, right? And another issues that tend to happen quite a bit nowadays is that you do not have a network. If let's say you don't have a network priority set for your OT like data information that's running around the network, right? So your network congestion can actually impact a lot of the critical systems if you don't only if you don't design it correctly. So if you put sort of a quality of service and then make sure that there's a few different ways to address it. Obviously, you can just have its own dedicated like a fiber network or something like that. But in most cases, especially in the packet switching world, you sort of need to guarantee it by having some sort of a logical mechanism to ensure that risk around network congestion doesn't happen. And to do that, you definitely need to establish that once again, as I mentioned before, very clear boundaries, very clear operational understanding of things, and how you generally when you do a sort of the interface management, you need to define the performance criteria and things. These are very critical when it comes to these sort of things, so that when you actually configure the system, these problems are addressed. And I think I sort of mentioned about the cybersecurity threats, how it's exposing more attacking surfaces. And to address that, you definitely need to have a holistic risk assessment around the IT/OT network impacts, because what you generally try to prevent is if there is a threat that's within the IT sort of domain, you don't want that to cascade it down into the OT network. So there are techniques like micro-segmentations and things like that to address it. You can have a sort of a different sort of systems architecture logic to address that as well. Okay, so I'll run through this one quite quickly. So the Industry 4.0 adoption, as I mentioned before, there's a huge amount of new systems that's brought in, like especially in the industry IoT world. And you probably noticed that a lot of the new the vendor offerings starting to utilize the cloud-based solutions. So, and this is basically just how IT has evolved over time, and their proposed solutions in OT is usually similar, right? Let's say if you have data analytics, they'll still be using, a lot of the vendors will still propose to use the cloud-based solutions, but they tend to do it without any sort of clear safety validations, like what that impact would be. And you obviously, because there's like lack of sort of understanding of a lot of these advanced technologies, you tend to increase that system complexity and unintended interactions between the subsystems. This is quite a common thing that you observe with Industry 4.0 adoption, especially with introduction of AI side of things as well. And then you'll see a lot of the modern day industry IoTs have edge computing, which has some sort of AI capabilities. So you'll see more and more of these sort of becoming an issue. And yeah, obviously, as I mentioned before, they'll always have a difficult maintaining regulatory compliance with these sort of dynamic systems that changes its characteristics quite frequently. So, so from the systems thinking approach, we can address these as well. So we really need to proactively assess a lot of these new technology impacts and on overall system safety, and you need to take quite a structured approach as well. So if you're sort of familiar with a lot of safety assurance or system assurance, you have probably gone through hazard and like hazard workshops and the SIL rating of the equipment. All these sort of fall into that. But one thing I noticed is that you need to sort of proactively trigger some of these, like based on the holistic view of the end-to-end system. So not just from like, oh yeah, this particular system component, but all right, like how does this new technology impact overall end-to-end system safety function? And incremental integration and validation is quite a common sort of method to use in order to address some of this risk that comes up. And obviously, it is one of those sort of agile approach where you actually iteratively integrating systems based on your integration strategy, understanding where some of these subcomponents fit, and you validate a system that sort of gets built to the full system, and that particular type of method is quite important when it comes to introducing these type of new sort of technologies. And yeah, and last but not least, but you need to have a very clear alignment between new digital technologies and legacy operations. So when I say legacy operations, it's ultimately what people that who uses the technology, and you need to understand how they would be interpreting the new ways of working, right? So it's almost like change management aspect of it, and you need to build that into your overall system viewpoint. Okay, and interconnectivity and dependencies. So once again, as I mentioned before, cascading failures is quite common when you have like a spider web type interfaces, right? And usually what happens then is it's very difficult to isolate faults. So if something goes wrong with particular subcomponents or interface between a particular subsystems, with these sort of if we don't apply system thinking, it's very hard to find where the issue lies, right? And as things are sort of getting more and more complex, one thing you almost lose track of is like, how does that actually have cascading impact to your safety critical operations? So keeping eye on that is really critical when it comes to operational technology in the modern days. And system thinking approach try to address that. I think this is quite a common practice everyone sort of across it, but yeah, your classic interface management attributes. So you really need to clearly define your subsystem interdependencies and interactions. But at the same time, you really need to have the holistic assessment from the top-down viewpoint of how overall systems impacted by some of these, let's say, failure points in as an example, in a particular interface. You need to have some sort of process or the tool or system in place to be able to see those cascading impacts, to ensure that we mitigate some of these risks, right? Okay, and I'll go to the legacy integration challenges. Yeah, I think this is something that everyone probably, especially in rail industry, faces quite a bit. So one of the big issue that I tend to find is that a lot of the old systems that just never documented well, which means that you have to reverse engineer quite a bit, and you actually have a very difficulties in achieving like a compatibility with a lot of the modern digital systems. So there's a modules or what we call sort of middleware that sort of addresses some of these issues, but those are not necessarily the best solution. And do we need to like look at, a lot of times you need to do a bit of a trade-off study whether that is like most feasible option or not. And yeah, you have to actually look at what the physical impact of things. So what are the sort of potential operational disruptions if sort of, especially with the migration, or if you have a staged rollout from the old legacy systems to this new system, you're always going to have the migration issues. And how does that sort of impact operations? It is quite a critical thing that you need to be very mindful. So I guess from the system thinking approach point of view, you once again you need to have the holistic view of how the legacy systems are have the dependencies emphasized. So you need to be able to have a clear indication how having this legacy interface is being introduced, or new modern digital systems being integrated into the legacy systems causes have what sort of impact that has, right? And you really need to have a very strong phased migration or integration strategy in place early in the project, to address some of these as well. What so just from my experience, if you leave it too late, um, it's almost like it can end up being a failed project because there are a few projects I have seen that happen. They leave a lot of these till so late, and then after they do the integration, they realize it's no longer fit for purpose, right? And that goes same with your compatibility and safety risks assessment. So you really need to keep very close eye on how these integration can impact the compatibility and the safety risks. And once again, very early in the projects. So, and given that we're talking about some safety aspect, what are the let's see what we can do about the regulatory and safety demands. So, some of the challenges that I tend to see is there's definitely increase in regulatory requirements applied. So, and and a lot of the times, especially if it's a IT-borne system, they're just never used to these sort of processes. So you end up with a project that's bringing in a part of the system that fits within the OT domain, but didn't follow any of the regulatory requirements. And you see that a lot with like modern day projects, OT projects as well. So that's something that we have to be very careful, especially when it's delivered by complete different parties. And there's definitely difficulty in demonstrating the compliance in these sort of like integrated systems, because people are so used to demonstrating compliance in a very subsystem viewpoint, so it's just not from the holistic view, right? So they might say, oh, our subsystem still rated, it's good to go, ready to go. We just have to bring all the SIL-rated systems together, build a system, and it's gonna magically become a compliant system. It's never the case. So, and that sort of generally comes from this difficulty in demonstrating the complex compliance in an integrated system. Another sort of risks, challenges, risks. There's always operational uncertainty around achieving acceptable safety and assurance levels. So. And this is something that needs to be managed throughout the project, almost like a continuous thing, right? So, and one of the biggest, I guess, tip in this case is that you always need to bring whoever's in charge of the safety very early on and get them involved in the process. But I guess just from the system thinking approach, how can we help, right? So one thing that systems thinking gives is that structured assurance approach, right? So you're linking your architecture elements, your requirements, risks, and your validation cases. You can actually have the structured assurance, and as soon as there's any sort of changes happen in the project, that change can be cascaded dynamically, and that is what you want to aim for, especially from the system, best practice in terms of system thinking approach. And you really need to be quite proactive about these as well. So in general, what I notice is that the projects tend to leave a lot of the compliance, like safety compliance assurance, till very late. and that can cause huge issues. So I generally encourage like projects to think about this like early in the stages of the project as well. And you really need to have that clear communication. So with the and make sure that whatever approach you're taking is always evidence-based, because that's what your ISA or whoever's approving their safety compliance or a regulatory compliance will look for. And obviously system thinking will help with that. Okay, I think we're nearly there. So let's see, how do we apply system thinking in the cybersecurity aspect of things? So as I mentioned before, cybersecurity is probably the biggest topic when it comes to OT systems. So I think majority of the IT/OT convergence risk workshops that I've been into is mostly about cybersecurity. um, for good reasons, right? Because it is probably one of the biggest risk items, and you'll probably notice a lot of other presentations around OT will IT/OT convergence will focus on cybersecurity as well. So one is given, increasing your attacking surfaces by introducing the um, IT integration. And thing is, the cybersecurity impacts on safety critical OT systems as well, right? So I think has been some cyber attack on a nuclear power plant, for example. That's huge safety critical issue. Um, and there's always difficulty in proactively identifying vulnerability across sort of integrated IT/OT domains because they tend to use a very different general policies in each of the domains. So how do you manage that is quite a tricky thing to think about. So from system thinking approach point of view, you really need to identify some of the cyber-related dependencies between IT and OT networks. So um, and this is quite critical because it's almost you need to provide an assessment in within the sort of the data comms point of view. You sort of need to establish a separate viewpoint in your architecture to distinguish some of these separately in order to actually um, address some of these cybersecurity risks. And there's quite a good frameworks around. SEPSA is one of them. There's a few other sort of cybersecurity framework that try to address this exact issue that can be utilized. Yeah, and once again, like I think the key word here is proactive. You really need to proactively uh, have a cyber risk mapped across the interconnect domains. And if you look at 62443 standards, it sort of like gives you guidance on how you sort of best put your subsystems system of interest or system of concern, and then you have how those interconnected domains are managed, and it sort of goes into details of how you can best manage some of these aspects of it, but that particular practice is very much based on the systems thinking approach. So it's probably worthwhile mentioning that. And another thing that I tend to see people don't quite do well is a lot of cybersecurity assessments. They sort of get done in silo fashion and treated completely differently. But you really need to put that into overall assurance framework for your projects, and try to provide that once again that holistic view of things. Okay, I will quickly go through the project, like sort of case study, and apply some of these things that we discussed so far. So this is actually based on the real project that I was involved in, where the vendor actually proposed a cloud-based analytic solutions for predictive maintenance. And there was like a few issues. So there was few security controls that was just not going to be worked with older hardware. There was definitely a policy gaps. There was no framework for safe interconnections. There was quite a huge amount of operational disruption risks, and especially like maintenance had a lot of complaint about the system uptime and direct access side of things. And the biggest loss of not the least, but the loss of trust between IT/OT and assurance team was quite evident at the time that I was involved in this particular project. It was like mistrust, and you seem to you tend to see that happen quite a bit in these sort of convergence type projects. So how do we sort of address this? So we got brought in to try to solve some of these issues, and one of the first thing we did was to create that holistic system view. So I think Jess sort of mentioned just before we started the presentation about SysML. So we actually use this SysML to model the full system of systems, including the legacy OT and proposed IT and cloud services. and also including human users and maintainers. So the modern architecture framework allow you to actually not just map the user as the systems, but it also allows you to treat the users, stakeholders as a system elements, right? So, and there's a whole framework around how to create a operational use cases around and this is sort of, if I'm sort of dive a little bit, a lot of people when we talk about systems architecture, they think about a design artifact, but it's not necessarily the case. So what I generally say is that it is a design vector. So it gives you a direction of how your design should be achieved, like it should be designed. It's not a design itself. So and another thing we did was, as I mentioned before, we integrated operational use cases into the architecture so that it was quite clear if, let's say, a subsystem interface has failed, then how did that propagate into impacting the operational use cases. And we also made sure that the IT integration as part of the system. So rather than treating as an external system, so they don't have to do anything about it, like they would follow their process. We brought them into the fold. We said our system boundary is this because our functional boundary starts from here and from there, which includes your subsystem. So you need to be part of that discussion. And to do that, we had to make sure we provide a system sort of thinking, system point of view for them as well. And there's a few additional stuff that we did. So we sort of redesigned the architecture for like better suited for the assurance criteria. So things like we started adding skill buffer zone across some of the high risk areas. We also use some of the defined protocols. We define the protocols like access roles and fallback mechanisms, which are all not a system design aspect of it, but it can be a sort of policy process, but it supports the assurance case for that. And yeah, enable the policy evolution via assurance framework. So having a strong assurance framework is quite key with some of these. So you need to have that upfront, like rule book to say how we're going to manage this throughout the life of the project, and the yeah, you sort of need to develop those assurance cases to demonstrate the risk factors. All right, this is the last one. So yeah, in the end, we managed to successfully made maintainers happy, so minimum disruptions, and we successfully implemented the maintenance analytics, and we had an acceptable, we addressed the security risks, and it was accepted by the assurance team. And yeah, and assurance achieved without any safety or compromising any safety and innovations. And biggest sort of success for us was we managed to get the ITOT, cybersecurity, and assurance stakeholders to all collaborate to the project, so a successful outcome. Okay, there's a few misconceptions in OT. I probably won't go through this in detail, given I've sort of gone over the time. So any questions from the audience?
Hi,
feel free to, yeah, go ahead, Bruce.
Hi, Edward. You mentioned in the cybersecurity a couple of standards. Which were they again? I didn't quite get them.
62443. That's the one that's quite commonly used in OT environment in transport nowadays. Yeah.
Okay, sorry, which one is that?
62443.
62443. Okay, I'll go and look at that. Thank you.
Yeah, no worries.
And one other question.
Yeah.
Are there any published papers from your work that you may have presented in open forum?
Published. Sorry, what was the question?
I mean, well, I'm just saying, have you presented open source on this kind of work in any sort of conference or anywhere?
No. So
No.
I've been doing more internally. So back when I was under public sector, I did. So this was sort of presentation almost given to quite a number of different business groups within that organization. I haven't really done any open forum, so called. So,
Okay.
but yeah, happy to work with Jess to I get this is probably one of the first one, I assume. Okay.
Awesome. I've seen Tom's got his hand up.
Thanks, Ed. That was awesome. You
All right.
mentioned there was initially a bit of mistrust between assurance, IT, OT. Was
Mm.
there any like one or two things that you did as a team to that really helped build that trust? Because it looked like you had it at the end.
Yeah, no, definitely. So I think communication is the key, and having this ground rule set quite early on in the project is quite important. So the one of the root cause of that, I guess, mistrust happened because IT team, for example, who was involved in the project had their own process, right? And then OT team has their own process, and assurance team has their own process to deal with these. There was a 3 different framework that was being utilized for delivering one system. And because they didn't have the holistic view, because yeah, sure, like from project point of view, you can deliver it that way, but ultimately end-to-end system is actually integrated, right? And to make this end-to-end assurance possible, they need to have some sort of come together and agree on that rule set, what we call rule set or the framework. So that was one of the first thing we did. And in order to support that activity, we had to very much clearly define the system boundaries and start putting together those architecture to ensure that they're comfortable with that. And one of the major, I guess, winning point was that by demonstrating the clear boundaries, and you can actually see the cascading like impact from one system to the other, they can sort of understand, okay, so that's sort of coming from our sort of domain, so we have to do something about it. So it actually gives them ability to make an informed decision as well. So that was sort of another thing. So I guess if I have to summarize it, one is definitely having that agreement up front in terms of like how we're going to approach this, and you need to have that very difficult discussion, especially if it's a division who's very much not dealing with a lot of systems engineering, for example. And then you need to sort of bring them into the fold and sort of be able to create a viewpoint for them specifically, so that they can contribute without having to learn about all these new like words and things like that, right? So that was the main approach we took.
Awesome. Thank you.
Yeah, no worries.
Hank, did you have a question for Ed? Oh, good. Ed, can you go back one slide?
Sure. This one?
So,
I think Nick's got his hand up.
yeah. I would just say that on this slide, you could just about substitute. You could replace OT with SE, and I swear, I've heard exactly the same things. So.
Yeah, I was gonna say that like I sort of ran out of time, but that was one of the comment I was gonna say in the meeting actually. So OT, so what people, and that's probably a good point, right? So one of the reason I work very closely with the systems engineering is that OT is not a specific discipline in a way. It is actually a almost like technical discipline that's integrating solutions together to serve particular operational purposes, right? And obviously, systems engineering is quite a well-established process and framework for dealing with that sort of complexity. So
yeah.
Sorry,
Awesome.
I think
Nick's got his hand up.
Hey, Nick.
I'm just on my mobile, so hopefully you can hear me okay.
Yep.
Yeah, great presentation. One of my questions was, been in a similar situation many years ago, integrating IT to airport systems, and so I can imagine some of the interesting scenarios you've gone through. At the time, we used to use a tool called Sparks EA to do the modeling, to create the views and stuff. But I was just wondering what tools you used for your diagramming to create your traceability views and how you found them.
Yeah, so this particular case study that I was describing used Sparks EA, so the same tool that you were mentioning before.
Cool.
But I've done similar exercise with use of tool like Capella. Also used the Rhapsody, which is the IBM tool set as well. So there's a few other tools that you can use to achieve sort of similar results. But yeah, I think if I'm being perfectly honest, all tools have a bit of a weird weird sort of thing they do. So you gotta be very careful with how much you rely on the tools set itself as well, right? So, but yeah, no, I think just short answer is yes, we use the enterprise architect Sparks EA for our project.
Awesome.
I was hoping you were going to say we used a certain new tool and it was really easy to get everybody on board using it. But if it was Sparks EA, you did.
No, I think one thing that I can sort of confidently say, and from my experience, is that you're never really going to have all the stakeholders come on board to use the tool set, right? So what's important is creating a specific viewpoint that's easily accessible by the users, right? So stakeholders who doesn't have to understand system or who doesn't have to understand things. So but ultimately the central model itself is basically same across whatever the viewpoint is. So so for me, my expectation was never for the users to use the tool, like go in and actually use the tool itself, but we would have a sort of almost like a middleware to make them easily accessible. So let them use their Excel spreadsheets, let them use whatever tool they're used to. But ultimately you need to sort of bring that how effectively you bring that information back into the model is probably what's important. And to be honest, I sort of in the mindset of unless this is really a model centric organization, you'll never have anyone buy in, not never, but it'll be very hard time getting everyone to buy into actually use the tool centrally. And that, at least that's from my experience anyway. So you have to make it easier for the stakeholders to contribute. Right?
Yeah, begin talking to you offline on some of those connectors, like you say, the Excel one and such. Yeah. Cool. Thank you.
All right.
Well, we are at full time. Thank you very much, Ed, for your presentation today. I'm just going to grab screen share back one more time. Replace current share, and I want that one to come up. Awesome.
Thanks.
Awesome.
Thanks, Ed.
So again, thank you, Ed, for your presentation this evening. I know that there were plenty of people who were interested who couldn't make it tonight, and I'm sure that they'll enjoy watching the video once we've got it up on YouTube. Our next get together is the annual general meeting for INCOSE NZ on the 29th of April, 1 to 2 p.m. If you don't have it in your calendar, let me know as soon as you can. And then finally, we expect that our next technical meetup will in fact be in late May with a topic and speaker that is to be confirmed. So thank you all for coming this evening. Thank you for your ongoing support of INCOSE New Zealand. And we'll see you all next time.
Okay. Thank you. See you all.
Bye. Thank you.